Hello, I'm Jacob Taylor, and I am currently working on how to implement a queue using 2 stacks for my data structures class with Mr. Perez. Today we'll be looking at how to implement a queue using these 2 stacks as shown here. Now, the first thing we need to do is understand how a queue works. A queue is a first in, first out collection, which means elements are added from the in here behind this element C and removed from here. So think of it as a line, as in the first person there will be the first person to get out, first come first serve, whereas a stack is a last in first out collection, whereas as elements are added to the stack, such as if we add A, B, and C, the first element to be removed will be C, because of the structure of the collection. Now, in order to understand how the queue works, we look at these 5 methods that every queue must be able to implement. First is enqueue. Enqueue is simply adding another element to the queue, which is simply adding another element to the last position of the queue. So if we added the element D, it would be A, B, C, and D, for a total of 4 elements in the queue. If we were to dequeue from the queue, the first element to be removed would be A. So if we would be left with B and C in this example. The first element is always the one to be removed. The first method tells us what element in the list, or in the queue, is the first one in the queue, which would be the next one to be removed if we were to be using the dequeue method. It does not remove the element from the queue, it just simply returns which element it is, similar to what the peek method of a stack will do. The size simply just tells us how many elements are in the queue. In this example there would be 3, A, B, and C. Is empty tells us whether or not the queue is empty or not, using a boolean. In this case it would say false because there are elements in the queue. Now, for stacks, they use these 5 methods, which are push, pop, peek, size, and is empty. Push simply adds another element to the stack. So if we pushed A would go here. From an empty stack, A would go here. If we were to pop from the stack, it would remove the top element, which in this case would be A from ABC. It would be element C, since it's on the top. Now, if we use the peek method, we simply peek at the top of the stack to determine what is currently at the top. In this case, it would also be C. So that's the similarity between the 2 collections, is that the peek and the first tell us what is the next element to be removed. Now, the size also tells us how many elements are in the stack. For example, this stack contains 3 elements. Is empty also does the same thing as is empty in the queue. In stack 2, it is empty, so it will return true. Now, in order to implement the enqueue method using a stack, using 2 stacks in the form of a queue, all we have to do is say we have an empty stack here, just like so. Okay, we're gonna say we want to enqueue A. We'll say we want to enqueue this whole queue. So what we will use is push the element we want. So push A, and we added A to the stack. Push B to the stack. push C, and push C to the stack. Now, by pushing this, we have reversed the elements of the queue, because now they will be removed from C, B, A, which reverses the queue, which is not how we want it to be if we were to be implementing a queue. So in order to make the queue back in order again, we would have to use the dequeue method, since if we wanted to remove A from this stack, or in this case A from the first position of this queue, we would not be able to do so using this stack here without losing these two elements as well. So what we have to do is transfer to the second stack by popping all three elements but pushing them into the other stack as well. So we pop C and push it into this stack, pop B, push it into this stack, and then pop A and push it into that stack. So now we have reversed the order again back to the original order, which is A, B, and C. And the next step will be to simply pop A, and that'll be the element we want to dequeue. So the queue will be updated and all will be left, which will be just B and C. Okay. But it's important to realize that now, if we needed to dequeue again, we could simply pop from the stack again. However, we want to keep these elements in order, so we will take these elements and we will simply pop them from the second stack and re-push them back into the first stack. Notice that at all times one of the stacks will always be empty, depending on which operation is being performed. So now we'll update the first stack if we were to reset the queue back to its original state after removing A. So using the two stacks we will now have B and C. Okay, like I said, we must always make sure that one of the stacks is empty, otherwise we're doing something wrong, which means we have elements that are being transferred and we're losing the original part of our queue. Okay, that's the simplest way of implementing enqueue and dequeue using two stacks. Now, if we wanted to queue another element, simply just add on to here, and it would repeat the process over again. Push it into the first stack. Now, if we want to use the first method, we simply do the same operations which we did for the dequeue method, which are to pop all the elements in the first stack, push them to the second stack, and pop the first element, set it to a variable so that we know that it is the top of the stack, and that is technically the first element in the queue that we want to look at. And then we push all the elements back into the original stack. That way we know what the first element is without actually removing it, since they are all put back into the first stack. It is important to keep track of that, because if you lose that element and actually pop it, then it is no longer going to be the first element in the stack, and you also completely changed your queue. Okay, the next thing we'll do is the size method, which is simply using stack.size to calculate how many elements are in the stack. So if we call stack.size on the first stack, it will return 2 in this example, since there are only B and C left in the stack. So if we were to have only 2 elements in the queue and wanted to use the 2 stacks to find the size, it would simply be stack1.size, and it would return the size of the queue. Now for the is empty, it's just as simple as the stack is empty, which is you call to check to see if the stack is empty. If it returns true, then you know that the queue is also empty. Both stacks need to be empty in order for the queue to be empty. Because if you have a stack that's full on this side, and then the stack that's empty on this side, you may not have completed all the operations of the queue, and it may be in a completely different order than how you originally wanted it to. Now, the only other thing left to do is the toString method, which can be done by simply following the operations from the dequeue and the enqueue methods, which is, first you need to check to see if the queue is empty, which involves checking both stacks again to make sure they're empty. If they are empty, then you know that the string needs to be returned that the queue is empty. Next thing you need to do is, while this first stack is not empty, you'll pop all the elements and push them into the second stack. Then, while the stack 2 is not empty, you will pop the element, concatenate it to the string you're working with and the element, and then push it back into the original stack in order to be able to keep the contents of the queue without losing them. And then you simply return the string you want to be able to print, and it will tell you all the elements in your queue. So that is the basis for how to implement a stack how to implement a queue, using two stacks. You simply use one stack to enqueue, which is you add all the elements in here in the first stack, and then you pop them into the second stack. That way you reverse the order. Then you dequeue, which is by popping the first element here, and that'll be removing example A from the queue, and then repushing all the elements back into the first stack in order to keep the queue back in order. It's important to take note that if you did not push the elements back into the first stack, if you were to enqueue another element, you would completely disrupt the order of the queue, and it would no longer be a first in, first out basis, which is the definition of what a queue should be. So if you do not follow that, it is not an implementation of a queue. So that is the basis of all of the operations that the queue must perform using two stacks. Alright, and that's it. Thank you. Bye-bye.